Hey, so we're picking back up with section 5.3. In this video, we're going to talk about the rational roots theorem, which allows you to find rational roots, being that is a rational number. So something that looks like a fraction or an integer. So we'll start with the theorem statement. And then we'll see it in action. So theorem statement, let f of x be a polynomial. So we'll say it looks like an x to the n dot 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 plus a1x plus a naught, where each each a sub I, so is an integer. Then P over Q is a factor of f of x if and only if P is a factor of a naught and Q is a factor of a n. So that actually really limits the possible rational numbers that could be roots of our function. So remember, a rational number is just something that looks like a fraction, like P over Q, where P and Q are integers. Also, all integers are rational numbers because you can pick P to be the integer you want and Q to be 1. So let's see how this works in practice. So for our example, we have this polynomial f of x equals 2x cubed plus 5x squared minus 11x plus 4. So now we have possible rational roots. So we want to write down all the possible rational roots. So for our numerators, our p, they have to be factors of 4. So we can have 0, plus or minus 1, plus or minus 2, and plus or minus 4 for p. And for our denominator, we can have factors of 2. So we can have 0, plus or minus 1, plus or minus 2. And actually, we're going to say our denominator can't be 0 because we don't know how to divide by 0. And so we put this together. So that's for Q. So then we get our roots are possibly 0, negative 1, positive 1, negative 1/2, positive 1/2, plus or minus 2. Doing plus or minus 2 over 2 is just going to give us back negative 1 or 1. And then we get plus or minus 4. And then doing 4 over 2, that's just going to get us back the 2 case again that we already had. So these are all of our possible rational roots. So if we have a rational root, it has to be one of these. And then we have to check all of these. And you might be thinking, wow, this is a waste of time. This is a lot of roots to check. And actually, there's some truth to it. This does take a lot of time, but we don't have a better way of finding roots. to a cubic. So this is usually one of the best things to try, and just hopefully we get a root out of it. And typically, if you're presented with a problem in a college algebra class that asks you to find all the roots of a cubic, and there's not something clear to factor out like an x, then doing the rational roots theorem is a pretty good guess on, it's a pretty good way to figure out the roots. Because it's a college algebra class, so they probably put in a rational root. I have some contempt with this theorem because, while it's helpful, in real world problems, you typically don't get rational roots, particularly if you're ever finding like the line of best fit or like a curve of best fit. It's very unlikely that you're going to have a rational root. Nonetheless, it's good for these contrived problems. And so we can just plug in values. We already know f of 0 doesn't equal 0 because it has a y-intercept of 4. So we can plug in f of -1, that's going to be -2, plus 5 minus plus 11, plus 4, which isn't 0. We can check 1, which is thankfully the one that it is. We get 2 plus 7 minus 11 plus, 2 plus, that should be 5, minus 11 plus 4, which equals 0. So we already just did 3 values on our list and we got a root. And now we can just do polynomial long division to find the other root. So our polynomial is 2x cubed plus 5x squared minus 11x plus 4. All right, so matching that 2x cubed, we're going to start with 2x squared. Get 2x squared minus 2x squared, the 2x cubed. We subtract this whole thing, get 7x squared. And we bring down the other side. We match the next term, so that's going to be a plus 7x. It'll be 7x squared minus 7x. Subtract that. We get minus 4x plus 4. And so matching that, we just get minus 4. Minus 4x plus 4, subtract, we get 0. And so then we get f of x equals x minus 1, 2x squared plus 7x minus 4. And then we just have to factor the quadratic, which we know how to do through the quadratic formula. All right. And as always, go out and practice this technique.